Hello guys, and welcome back to Engineering Hack, where we try to solve engineering problems in a way that's hopefully easy to understand. Today we're doing a very simple yet very important problem in the realm of thermodynamics, which is related to pure substance analysis. The idea here is, can you find the properties for pure substances on the property tables, and if so, apply them? And this is just, one-on-one on how to find these properties. So the problem statement reads, a 2 meter cube tank contains a saturated vapor at 40 degrees Celsius. Determine the pressure and the mass in the tank if the substance is steam, ammonia, or Freon 12. Freon 12, which, if you don't know, is the commercial name for the CF2CO2, right? So carbon, chlor. This is a gas, and it's used often as a refrigerant in different applications such as air conditioners and fridges, etc. Not sure if it's been banned or not. Might have been banned already because of its harmful effects on the ozone layer. All right, let's not lose track. So the idea is I have a tank, and depending on what I have in this tank, the tank, regardless of what I have inside, the tank is always going to be at 40 Celsius, and it will always be a 2 meter cube tank. So what will change as we go from one substance to the other is specific volume, right? Because depending on the substance, we're going to have a different specific volume, and then that means that the mass content inside will be different depending on what we have, all right? And likewise, the pressure is also going to be different. So if we have steam, what do we do? Well, we'll go to the steam tables. We're all going to go to the property tables and then look for these two things. Note that we're always on a saturated state, right? Always on a saturated vapor state. So whatever the saturation temperature or pressure is a pressure that we are looking for to be able to solve this, right? So that's going to be super straightforward. Whatever pressure we find for that temperature will be the pressure we're looking for, and then the mass, we just need to do a quick math to find out. So I have my Rogers tables here, and I'm going to go first to water. Water, and I'm looking for water at 40. So this is the temperature here. I'm looking for water at 40, so this is the line I'm interested in. And like I said, the pressure, very straightforward. Whatever pressure is here, so 0.073 in bar, that is the pressure of my state. Okay, so very straightforward. That's going to be the pressure of my state. So about 7.3 kilopascals or 0.03 bar. And then for the mass, what I do is I take this value here, which is the value of the specific volume in meters cubed per kilogram. Okay, so I'm going to grab this value here, the 19.55, and I'm going to use this to be able to calculate the mass of my tank. Okay, because we didn't know that specific volume. Just by looking at the units, we can see this is volume by the mass, and therefore, if I'm looking for the mass, all I need to do is take my volume and divide by my specific volume. So I have 2 meters cubed, that's my volume, and I'm going to divide that by the 19.55 meters cubed per kilogram. I'm going to grab an answer in kilograms, and in this case, this is going to be 0.1 kilograms, so specifically 0.1023, and it goes on, but we can stop here, and that's going to be the mass in the tank if we have water. Okay, what if we have ammonia? So then, obviously, this table here doesn't really do us much, so we need to go down out of the water tables and down to the water tables, out of the water tables, and then look for tables for other substances: supercritical steam, water and steam, compressed water, and then there you go. Now we start different substances. So we have mercury here. We have ammonia. There you go. So we're looking for ammonia. We got ammonia. And once again, I'm going to go down to 40. So my temperature here, I'm going to look for 40. Whatever I find on this bar here is going to be the pressure, because this is a saturated vapor. And whatever I find here for the specific volume I'm interested in grabbing to be able to calculate the mass. Okay, so 40, there you go. Interestingly, the specific volume is out of place for some reason, but there it is. And therefore, the answer for this, if it's ammonia, the pressure is going to be 15.44 bars, and the mass is going to be just this 0.0833 in meters squared per kilogram that I need to. Mass will be the volume divided by specific volume, so therefore the 2 meters cubed divided by the meters cubed per kilogram, which will give me an answer in kilogram, and that will be 0.24, approximately 24.01 kilograms. Okay, so note that under the same conditions, we would have way more ammonia than we would have water in a volume of 2 meters cubed. All right, what else? Next up is the Freon, right? Freon 12. So same thing, just need to keep going. And we find refrigerant 12, the chlorodifluoromethane. That's a very fun name to say. Same idea, okay? I'm looking here for 40 on the temperature scale. And then I'm going to say, okay, if this is the properties at 40 Celsius, then the pressure, because and only because this is a saturated vapor, is 9.6 bar, and the mass will be 2 meters cubed divided by the 0.182, which is the only thing I need to use to be able to calculate the mass. So mass will be volume by specific volume, in this case 2 meters cubed divided by my 0.01 meters cubed per kilogram. Which means that if I were to have Freon, I would have 109.9 kilograms of Freon in there. So know how different it is depending on the substance you have in there. Okay, so there you have it. Like I said, straightforward question. If we had steam, we would have only about 0.1 kilograms. If it were ammonia, it would be about 24 kilograms. And if we have Freon 12 inside at 40 Celsius, then we would have 109 kilograms and 2 meters cubed. All right, I hope this helped you out. If you have any questions, as per usual, just leave them down below in the comment section. If this video was useful, consider giving it a like, and we'll talk soon.